Hello everyone, this video introduces how to use PIE Ortho to produce regional ortho map step by step. The data used are as follows: 2 GF1 original images, base images, and DEM. The process flow is as follows. The first step is to generate a panchromatic or ortho image. The panchromatic ortho image is used as the base image to generate the multispectral ortho image. Finally, we force the ortho images. From the menu bar, select the project. Click New Project to open the New Project dialog. Name the project. Select the project, save path. Click OK. Set project module. We select the digital orthophoto map module. Click Next to enter the image selection dialog. Select the panchromatic image in the Image tab. Click Add. Select the panchromatic image. Click Open to add the panchromatic image to the list. Select the base image in the Image tab. Click Add. Select the base image. Click Open to add the base image to the list. Select the DEM data in the Image tab. Click Add. Select the DEM data. Click Open to add the DEM data to the list. After adding images, click Next to enter the projection coordinate system definition interface. Select the base image projection by default. Click Next to enter the output path interface. Select the default output path settings. Use the resolution of panchromatic ortho image and multispectral ortho image by default. Click Finish to complete creating the project. Because image premiere file are involved in the calculation, it is necessary to create a premiere for the original image first. Click the Pre-image Creation tool under the Processing module to open the Premiere Creation dialog. Click the Import Original Image button to import the original image, and click the Process to start processing. After creating the pre-image, click OK. Type point generation. Click on the Type point generation tool in the Block Adjustment module to open the Type point generation dialog. Image mean overlap. It describes the minimum overlap between the images by setting this parameter. The density of type points can be adjusted. The default value is 3%. If the overlap area between images is small, reduce this value accordingly. Texture quality. It describes the texture similarity between the images. The default option is general. If the images in the project are from different sensor, or texture differences is large, or the texture is weak, you can choose worse. Use the fruit of arrow triangulation if the data has been done triangulation. According to the actual requirement, choose whether to use the existing triangulation results as the initial calculation file to participate in the calculation. Search readers. It describes the search readers when automatically extracting type points. The larger the reader's value, the wider the search range, and the greater the probability that the type points will be successfully matched. Whether to rotate it. For the images with large differences in orbital direction, after this box is checked, the image will be correct without GCP firstly, and then the correct image are used to generate type points, thus improving the quality and accuracy of type points. Error threshold. It is standard RPC model error threshold. Control points with their errors larger than the threshold will be automatically removed. The larger the threshold is, the larger the number of control points will be. However, there may exist wrong points. The default overvalue is 15 pixels. Delete. After this box is checked, the type points that error value greater than the threshold will be deleted. After setting all parameters, click OK to the platform type points extraction. The project log records the calculation starting time, the completion time of each synth, and the total time, and so on. After the time points are extracted, we can view the description of the type points. When the residual value of the type points before adjustment is 0, click Plain Block Adjustment module, including conventional block adjustment and Sparse GCP Block Adjustment with GCP by field survey. Conventional block adjustment. This module is suitable for the case where there exists base image and control points are generated by PIE also automatically. Sparse GCP Block Adjustment with GCP by field survey. This module is suitable for the case where there exists no base image. Use sparse control points acquired by field survey to perform adjustment, rather to generate the RPC file. If this point is checked, the RPC file of each ortho image will be automatically generated and saved in the new RPC folder of the project path. The weight of GCP. Set the weight of GCP points in the adjustment process. The default value is 10. Racine threshold. The smaller the value, the higher the adjustment accuracy. The more control points will be deleted. The default value is 1 pixel. Maximum interactions. The more the interaction, the longer the time, the higher the accuracy. The default value is 50. After setting all parameters, click OK. Each type point has a corresponding residual value after adjustment. Click Add Point Map button. In the main view, click the mouse where the matching points are sparse, and the point measurement dialog appears. Taking the root intersection as an example, slide the mouse wheel, enlarge the image, and adjust the position of the type points. We can move the type point to the new location by clicking the left mouse button on the root intersection, and we do the same operation on the type points of another image. After adjusting the position of the type points accurately, we click Add a New Point button to open the Points Added dialog. New Point Type. Select Point Type. Tap Standard for Type Point. GCP Standard for Control Points. CP Standard stands for Checkpoint. New Point ID. Enter ID for new point. After setting all parameters, click OK to complete editing. Click Edit Point Map button. Choose the type point on the type point overview and click it to open the point measurement dialog. In order to move the point to a clear road intersection, click the left mouse button on the road intersection and to adjust the point position. When the point accuracy meets the requirement, click Confirm Current Modify button to move the point to the correct position. If the modified point is inaccurate and there is no clear object around it, as a new connection point. Click Delete to delete the type point. Click the descending order. In descending order, the type points can be arranged from large to small according to the residue value. Double-click the point with the largest residue value in the point list. Open the image point measurement window to check the position accuracy of point and adjust or delete it. You can also click the button to open the Remix Delete dialog. Input the residue threshold in the text box. Select the TPT tab and click the OK button. The dialog will show the number of connection points larger than the threshold and prompt whether to delete. Click Yes to delete connection points larger than the threshold. After editing the type points, click the Plain Block Adjustment to block adjustment again and click OK. Control point generation. Click the Control point generation button to open the Control point generation dialog, and then click Select All to select all data in the image list. Texture quality. It detracts the texture similarity between images. The default option is general. If the image in the project are from different sensor, or the texture difference is large, or the texture is weak, you can choose worse. Default C point number. Set expected control points number of each image. The larger the value is, the more control points will be generated, and the slower the software will run. Geometrical uniformity. It describes the geometric uniformity of the target image and base image, such as the poor geometric uniformity caused by Photoshop software pulling on base image for a better edge effort. If the generated control points are uneven or rarely, you can choose worse. Whether to use the fruit of arrow triangulation. If the data has been done triangulation according to the actual requirement, choose whether to use the existing arrow triangulation results as in the initial calculation file to participate in the calculation. DEM invalid value regulation does not output. If the option is checked, DEM invalid area will not participate in the auto rectification process. DEM invalid value can be default or set by yourself in the text box of DEM invalid value. Ignore 0. If the option is checked, the image invalid value will be ignored during the process. Click the Advanced Setting button to open the GCP Generated Advanced Setting dialog. Search Radius. It describes the search radius when automatically extracting control points. The larger the radius value is, the wider the search range is, the greater possibility that the control points will be successfully extracted. Error threshold. It is standard RPC model error threshold. Control points with their errors larger than the threshold will be automatically removed. The larger the threshold is, the larger the number of control points will be. However, there may exist wrong points. The default value is 3 pixels. Similar threshold. Equivalent to the quantitative index of texture quality. The larger the value is, the higher the texture similarity is. After setting all parameters, click the OK to platform control point generation. And we can view distribution of the control points in the point measurement interface. Click on Describing Order button to edit points with larger residue value. The unqualified points can also be removed in the benches by threshold detection tool. After editing the control points, click the plane block adjustment to block adjustment again. After block adjustment, we need to recheck the distribution of control points and the residue range, and edit control points again until the accuracy of control points meets the project requirement. Select the Digital Ortho module button under Advanced Image Produce to open the Digital Ortho model dialog. Click the Select All to add all data in image list. Output projection. Display the projection information of output image without DEM. If there is no DEM data, check the option to active evaluation constant setting and set the average evaluation of the test area. Interpolation method. There are three interpolation methods including nearest neighbor interpolation, bilinear interpolation, and cubic interpolation. The default is the bilinear interpolation method. Tiny crack. Tiny crack means tiny factor of differential rectification. Only valid is image registration model. You can check this option when the internal geometric uniformity of the base image is uneven. For example, the image has been dragged by Photoshop, or if the source image is geometrically accurate, is bad and not suitable for standard RPC plus affine transformation model. Thus, the cracked image will be fit better to the base image. The tiny crack requires control points to be absolutely accurate and uniformly distributed. Generally, there is no need to select tiny cracked. DEM path. Displays the path of DEM data if there is DEM in the project. Otherwise, select the path and name for DEM data. DEM involved value region does not output. After checking this point, set involved value for the DEM data. Then, involved value area will not participate in the ortho rectification processing. After setting all the parameters, click OK to platform Digital Ortho map production. After DOM production tasks are processed, click OK. After completing the production of panchromatic image, we begin to produce a multispectral image. Click the Image Information button under the Project Modification to open the Image Information dialog. Delete the panchromatic images and the base images. Choose Multispectral Image for Image tab. Click the Add to add a multispectral image. The orthophoto panchromatic image is added as the base image. After the addition is completed, click OK. Click on the Type Point Generation tool under the Block Adjustment module to open the Type Point Generation dialog. After setting all the parameters, click OK to start the Type Point Generation. We can click the Point Measurement button to view the distribution of control points and click the Plane Block Adjustment. After the parameters are completed, click OK. Check and adjust the connection points and remove the unqualified points by threshold detection tool. After editing the type point, click on the Plane Block Adjustment to block adjustment again. Click on the Control Point Generation tool to open the Control Point Generation dialog. Add the image to be processed in the image list. After setting all parameters, click OK to platform control the points generation. After generation of control points, click the point measurement to check and edit control points. And remove the unqualified points by threshold detection tool. After editing the type points, click on the Plane Block Adjustment to block the adjustment again. After the accuracy of control points meets the requirement, we can begin to output the orthoimages. We can begin to output the orthoimages. Select Digital Ortho Model button and the Advanced Image Product. To open the Digital Orthoimage dialog, click the Add All to add all data in the image list. After setting all parameters, click OK to product the multispectral orthoimages. Close project. Select the Image Fusion button and the Advanced Image border to open the Image Fusion dialog. Click the Import Panchromatic Images and select the panchromatic orthoimage to add. Click the Import Multispectral Image to select the multispectral image orthoimage to add. Click Add All to add Fusion image and base image. After setting all the parameters, click OK to platform. Click OK to perform image fusion. Right-click on Map in the layer list and select Open Raster File to load images. Reload the fusion image and the base image to check the accuracy of fusion results. Click the Swap layer of general function. We can check the accuracy of fusion image result with Swap layer.